Welcome to Center of Math's Advanced Knowledge Problem of the Week. For this week's problem, we want to prove that the alternating group AN of a set 1, 2, n is generated by cycles of length 3. So since we're dealing with the alternating group, we can represent any permutation of 1, 2, 2, n as a product of an even number of transpositions. So we can consider a couple cases. The first case we can consider is when the two transpositions are equal to each other. So these two transpose two elements A1, A2. They both do the same thing, so these are going to be equal to our unit element E. It won't affect our group actually. So these two we can always combine into a unit element. So this case we see, and this is part of our, well, if this comes up in any representation of a member of the alternating group, this can just be condensed into a unit. So let's consider when two of the transpositions have one element in common. So say two of them have A2 in common, then we can combine these to just write it as the cycle A1 and A2, A3. So A1 to A2, A2, A3, A3, A1. And so we can see here A2 gets sent to A3, same here, A3 gets sent to A2, A2 gets sent to A1, so A3 is getting sent to A1, and A1 getting sent to A2. So these two send A1, A2, A3 both to the same thing, so they're equal. The last case we have is when the two transpositions have no elements in common. So say we have A1, A2 product with A3, A4, these two transpositions. We can write this as a product of 2, 3 cycles. So A1, A4, A3, A4, A2, A1. A1 gets sent to A4, A4 is sent to A3, A1 gets sent to A4, A4 gets sent to A2. So we see A1 gets sent to A2, same as here. If we go through all the other elements, we'll see they all get sent to the same thing. And so we see that given any two transpositions, we can write their product in terms of either the unit or 3 cycles. And so since we're dealing with the alternating group, we can write any member of it as a product of an even number of transpositions. So just group up these transpositions into groups of 2. For each 2, they fit into at least one of these cases. So for each 2, write them as a product of 3 cycles or the unit, and we get each alternating group is representable as a product of 3 cycles. And so from that we can conclude it is in fact generated by cycles of length 3. Thanks for watching. Please check out centermath.org, check out our blog, and follow us on Facebook and Twitter. Thank you.